For dramatic effect, you go turn off the lights for a moment, please. Oh no, we just lost power. Okay,
Oh, no.
that's the fun part. Okay, turn it back on.
Hooray.
But you've been out of power now for 2 days. Okay, 2 days out of power. What electronic devices do you have at home you want charged?
The microwave.
Amen.
Freezer.
Yeah, the freezer.
You can charge a freezer.
Okay,
I don't know
not
what to do.
appliance. What electronic devices do you want charged?
Phone.
A phone?
Radio.
A radio?
Computer.
A computer? Okay, there's a difference between an appliance and an electronic device. Okay, we'll talk about those in a minute. So let me ask you this. How long did it take for the pioneers to walk from winter quarters to the valley? 3.5, 4 months probably, right? Okay. Please name your grandmother's bread mixer.
Your hands.
How about the wheat grinder?
Stones.
They probably went to the mill, right? Yeah, which was just down the street in the next county, right? Somewhere convenient. Okay, so that in thought, how many of you, if the power goes out for day 3, day 4, day 5, want to live like a pioneer? Or your grandmother? Okay, this class to help fix that. Okay, to help fix that. I really put a lot of emphasis in teaching you how to identify what the limitations are of a solar panel or a generator, so you can go out on the market and make an informed decision on what kind of products you might want to buy to service the needs you have. Okay? That's a real important distinction in how I worded that, because I didn't say anything about refrigerators. Okay? Right now, we're only 5 days into this now, maybe 6, maybe 7 days. So be mindful of what appliances you want to have recharged. So right now, we're going to talk about the recharging of items that already have batteries or are very small and you can easily pick up and move around. Okay? Please, let's exclude electric heaters from this discussion. Okay? Electric heaters from this. They are pigs. Okay, so now, who has a handout? Who does not have a handout? Who does not have a handout?
I got him.
Okay. We're going to do a little chalk talk with the handout. Does anybody know the differences or the correlation between voltage and current or amps? Maybe 1 or 2 people might. How about this, for example? Voltage is like pressure. Okay, it's pressure. And you can imagine different kind of pressure, water hose. The more you have it turned on, the higher pressure it is, right? And the size of the hose would be the current, or the amps, is what we'd say. So let's just use this as an example. Okay, just go. I got my trusty voltage and current meter here. I'm going to point it. How much water is going to come out? Not very much. But I'm generating pressure, right, by how fast I pull the trigger, right? And the size of the hole or the current depends on how much comes out. Can we envision that, right? So no matter how hard I pump this bad boy, it's going to take me a long time to fill up a 5-gallon bucket. Would you agree?
Oh.
Okay. So this is a AAA battery, okay, or a AA battery. Okay, now, a little bit bigger. More pressure, more voltage, bigger hole at the end, which means what?
More amperage.
More amperage, more current. Okay, so if you think of those two things, the more pressure we have, okay, and the bigger the hole, or the bigger the pipe, or the bigger the wire, the more current it can carry. We got that? So that's an important correlation. All right.
Say that one more time, Brett. More pressure.
the more pressure there is, it's higher voltage. So this, instead of being a AA, okay, could translate into a car battery. Bigger capacity, holds more water. I can have more pressure on it, and the hole's bigger. Okay?
But you said bigger hole and wire carries more, what?
Current. Amps.
Amperage.
More amps.
But the amperage is what will kill you, not the voltage.
So we're not going to talk about death. You know, just because I brought guns to the church. Da, da, da. Okay. So that correlation. Now let's think of this. We're going to do some math now. How can you determine the miles per gallon you get in your car? What's the ratio? Miles, how many gallons, right, equals what?
Divided by gas.
Okay, so that's a correlation. You look on your handout, on the second bullet there, it's miles per gallon. It's a correlation, it's a ratio we do all the time. The same thing with voltage and current. Okay, it's the same kind of correlation. They are together in the fact that they, how do I say this? You can easily determine one if you have the other with a third item. So in this case, look at number 1A. Car gets 20 gallons holds 20 gallons of fuel. The same car travels 200 miles. What is the miles per gallon? So it's 200 divided by 20 equals 10 miles to the gallon. Must be a truck, right? So, and 1B says the car gas tank holds 20 gallons of fuel. A car gets 10 miles to the gallon. How far can the car drive? It's the same numbers, just put a different relationship. Okay, it's the same thing with current, watts, and voltage. They're interrelated. So let's not get caught up on the verbiage or how difficult the math is, because it's the same relationship. Now this is important because this drives our decision of what kind of technology, solar panel, generator, or something else, that will drive these other kinds of devices. That's why we're going to spend some time on it. Now let's look at item number 2. We know what volts is, it's pressure. We know what amps is, it's the size of the hose, or how much water could come out of my squirt gun example. So a battery capacity holds 20 amp hours. Instead of gallons of water, a battery is rated in amp hours. Okay, how many amps can a battery produce in a given hour? So if this was a 20 amp hour battery, it can do, as an example, 20 amps for 1 hour, or 20 amp hour. It can sustain 20 amps for 1 hour, or 1 amp for 20 hours. You see the correlation? A 20 amp hour battery can do 20 amps for 1 hour, or 1 amp for 20 hours. Okay, 20 amp hour battery. So a 20 amp hour battery, with a blender that consumes 5 amps, how many or how long will the battery last? So 20 amps hours divided by 5 amps, 4 miles per gallon here. How big is your gas tank? 20 amp hours. How many gallons or how many miles per gallon can you get? Right, it's the same relationship. Now one more, so number 2D is, if the battery lasted for 4 hours, and this is very normal, right? You can do a test yourself. The battery will last for 4 hours. Okay, right? We do that all the time. How long does the battery last? Not very long. But how long? 4 hours. Okay, so if the battery lasted 4 hours, and you know the blender consumes 5 amps, how big was your battery? 20 amp hours. So you see the same correlation we did with the miles per gallon? The same thing with volts and current. Okay, now you're almost an electrical engineer. Okay, all you need now is a pocket protector. So,
10 pins to put in.
and it's a pin. Yes, I got rid of my pocket protector. People think they're funny. I think they're great.